So in this video, I'm going to discuss the alter ego problem which occurred in today's CODECHEF challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I provide both the links in the comment section. I'll pin them. The problem statement is very simple. You're given an array. The size is given. The size is always an even number, and you have to find that whether there exists an alter ego of that array. What is an alter ego of an array? Sorry. I meant that there exists an array which is whose alter ego is this array, okay, like something like that. Okay, so what is basically what we have to do is we have to find an array such that, so like see, for this, the if you divide a partition over here, so 7 plus 3 is 10 and 7 minus 3 is 4, right? And then go for them, 5 minus 3 and 5 plus 3. 5 plus 3 is 5, 6 and 8, and 5 minus 3 is 2. And for this 3 and 1, 3 plus 1 is 4 and 3 minus 1 is 2, right? So if we check 2, 2, 4, 4, 8, 10, so 2, 2, 4, 4, 8, 10, right? So this is a permutation of this thing. Okay, so this is what the basically the code demands. Like for this also you can check 4, 0, 4 plus 0 is 4 and 4 minus 0 is 4, and 4 plus 1 is 5 and 4 minus 1 is 3. So 3, 5, 4, 4. So 3, 5, 4, 4, right? This is a permutation. But over here there exists no array from which we can derive this. Okay, now the basic thing, you can see one thing from here, that is, if this plus this, let's say this is an even number and this is an even number. Okay, so we are going to like consider 4 conditions, that is even, odd, even, and odd. So if both of them are even, the addition and subtraction. Okay, so let me draw a table over here. Addition will be even, addition will be odd, and this will be even. Okay, and the subtraction of even and even is even and odd is odd, even and odd is odd, and odd and even is this, right? So you can see one thing, that there is a very good similarity, that is, whatever is the parity of the addition is also the parity of the subtraction, right? So that means number of even numbers should be even and number of odd numbers should be even. So the -1 case is case 1 is when we will print -1, right? When there is a odd number of odd numbers. Okay, a little bit like very tricky to hear, but when there are odd number of odd numbers, that over here, see, there is only one odd number, so that is a odd number of odd numbers, so this is a -1. But for this 3 and 5, there are 2 odd numbers, so this is okay. For this also there is no odd number, so this is also okay, right? Clear? So this is the proof for why -1 happens. Now let's go to case 2, that is, we have to make an array. Okay, now remember one thing that is given in the question. We have to form something, so we have to find the output such that the sum of all the elements of the array is as maximum as possible. Okay, now how we are going to do this? So remember one thing, if we know that this is the like array, so first of all we know that even and even are going to pair up and odd are going to pair up, right? So first of all we can divide the whole array into even and odd, right? For this, the odd are 3, 5, and the even is 4, 4, right? Now that this means there is a x plus y which is 5 and x minus y which is 3. Now if we calculate it, we know that the addition of both of them becomes 2x and the subtraction of both of them becomes 2y, right? So what we can do is, so let's say this is a and this is b, so x is basically a plus b by 2 and y is basically absolute value of a minus b by 2, right? Similarly for this also the same thing happens. Now we have to maximize these two values. Okay, a plus b by 2 and a minus b. Now when is it going to be maximized? This is one thing. Okay, since this is a plus b by 2, so there is no condition of maximizing this. Okay, so there is no condition of maximizing this, but since this is a minus b by 2, so this two extremums are going to give us the maximum value. Okay, so let's say if we have, let's say there is a number line, okay, and there are some points, and if we subtract them, so we get this value, then if we subtract them, then we get this value, and if we subtract them, then we get this value, right? So the answer is the addition of all of them is going to be this plus this plus this, right? But if we subtract this and this, we are going to get this value. Then if we subtract this and this, then sorry, this and this, then we are going to get this value. If we subtract this and this, we are going to get this value, right? Clear? Now if you check this one thing, so this is getting repeated 3 times, this is getting repeated 2 times, and this is getting repeated 1 time, right? So this is a better approach, right, rather than like subtracting the consecutive ones. So the greedy approach is to first divide the array into even numbers, odd numbers, then sort them, then perform the operations for the extremes, okay, for the extremes, and you will get the answer, right? So let's do it for this one also. Okay, 4 2 8 2 10 4, so 10 4, yes. Now if we sort it, it becomes 2 2 4 8, so there are 2 4s, right? 4 4 8 10. Now see how we are going to find this. 2 and 10, we are going to first consider 2 and 10. So what is the plus? It is 12, and 12 by 2, then there is 2, 10 minus 2, that is 8 by 2. Then we are going to consider these two, so 8 9 10, that is 10 by 2, and 2 minus 8 is, sorry, 8 minus 2 is 6 by 2. Then we are going to consider this 2, right? 4 and 4, that is 4 plus 4, 8 by 2, and 4 minus 4 is 0 by 2. Okay, clear? So what is it coming as? 12 by 2 is 6, 8 by 2 is 4, 10 by 2 is 5, 6 by 2 is 3, 8 by 2 is 4, and 0 by 2 is 1, right? Oh sorry, one, I made a mistake. Since it is given that we have to like divide it, so basically we can write it as, first we are going to write 12 by 2, that is 6, and in a separate array we can write 8 by 2, that is 4, right? Because they are pairs, right? They are pairs. So 10 by 2 and 6 by 2, that is 5 and 3. Then 8 by 2 and 0 by 2, that is 4 and 0. Now according to me, my answer is going to be 654430. But if you look at this solution, there is 753331, not the answer, right? But if we add it, so 7 plus 5 plus 3 plus 3 plus 3 plus 1 is 22, okay, and 6 plus 5 plus 4, it is 15, 15 plus 4 5 7, 15 plus 7 is 22. So the addition of both of them is equal, right? Now we have to prove that this is a valid solution or not. So if we divide it, so 6 and 4 10, 6 minus 4 2, 5 and 3 5 is 8, and 3 minus 5 minus 3 is 2, 4 plus 4 8, 4 minus 4 is, so I made a mistake, so that is going to be, so 6 and 4, so 6 plus 4 is 10, and 6 minus, so 6 and 4, that is 6 plus 4 is 10, and 6 minus 4 is 2, and 5 plus 3 is 8, and 5 minus 3 is 2, and 4 plus 0 is 4, and 4 minus 0 is 4, right? So 2 4 4, so 2 2 4 4 8 10, right? Over here you can see that it is 2 2 4 4 8 10. So this is a valid case. So similarly you have to do for the even numbers and the odd numbers separately, and once you're done with it, so you get the answer. That's it from my side. Thank you.